Hey guys, how's it going? All right, guys. I hope that everyone is safe and healthy at home, guys. Like that. I know that for a lot of you guys who are self-isolating right now, this is very frustrating, like that. And I just hope to see you guys back at school soon. So sorry, guys. This is one of the topics that was not in the D2L shell yet. So it's thanks for your patience and reminding me that I didn't have this one done yet. So topic over here is called intersection of lines and circles. Okay, so for those of you guys that are in my AP class, you'll need to kind of follow through these examples, and then the last two examples are going to be like AP examples. So if you're in my regular class and you're watching this, guys, the last two examples, feel free to go through and do those ones as well. But there'll be probably questions I'll have on the AP test and definitely not on a regular test. All right. So the topic is called intersection of lines and circles. So quick little review here, guys. And for the APs, guys, we've done this topic before, but for the regular 20-1, guys, we have not covered the equation of a circle yet. And here's how it goes. So this is a circle, and the center is at HK. And the radius equals R, okay? So we're going to call it this. Now, guys, this is HK. This is a general point. This point does not have to be down here in quadrant 4. It could be up over here. It could be over here. It could be over here, okay? And the circle over here right now, the circle could be bigger or smaller like that. This is just a general equation for a general circle, okay? So what I'm going to do is I'm going to draw the radius. Oops, that was not a very good radius. I'm going to draw the radius from here to here, and I'm going to draw a triangle that looks like this, okay? Now, labeling this triangle, we're going to have from here to here is the radius, so we're going to label this one R. Now, the horizontal leg of the triangle is going to be this value, whatever this value of x is, minus this value of h. It's going to be x minus h. This leg of the triangle from here to here is going to be y minus k. So y minus k. So what we have here is we have a right triangle, and one of the ways we can relate to the three sides of a right triangle is with Pythagorean theorem. So if this is like A, B, C, this is going to apply to x minus h squared plus y minus k squared equals r squared, okay? And so this is the equation of a circle. All right, so for this guy over here, we're going to determine the equation of the circle. And so we're going to start with write out our formula for that. It's going to be x minus h squared plus y minus k squared equals r squared. Now looking at this guy over here, I hope you can see that the center of my circle is going to be, nope, not 6, 6. It's going to be it's going to be 1, 6, okay? And if you look from here to here, this is like, if I'm looking at what the radius is going to be, it's going to be 1, 2, 3, 4, 5, 6, 7, okay? So we know that HK equals 1, 6, and we know that R equals 7, okay? So therefore our equation is going to be x minus 1 squared plus y minus 6 squared equals 7 squared, and 7 squared is 49. So here is the equation of our circle right there. All right, similar idea for this guy over here. Negative 4, 2 is our center. And our radius is going to be 6 for this case. So our equation is going to be, this is going to be x minus negative 4, so it's going to simplify to x plus 4 squared plus y minus 2 squared equals 6 squared, which is 36. All right, so I'm over here, guys. We're not giving you the picture anymore, but really, guys, we're doing the exact same way over here. So we're doing, sorry, not exact same way here, guys. So what happens here is we do not know what our R value is, okay? But guys, anytime, and so this goes for like a whole bunch of different functions in this course as well. Anytime that a graph passes through a certain point, we call that point xy, and this center is going to be hk. So plugging this into this equation over here, we have x minus h, so it's going to be 9 minus 5 squared plus negative 12 minus negative 8 squared equals r squared. This is 4 squared. Negative 12 minus negative 8. Add the opposite is negative 4 squared. This is 16 plus 16 is 32 equals r squared. Okay. Now, we don't need to square root both sides here because the equation of a circle is x minus h squared plus y minus k squared equals r squared. So r squared equals 32. So this is going to be x minus 5 squared plus y plus 8 squared equals 32. Okay. Same idea for this question over here, centered at negative 2, 1, passes through 9, 5. All right, so we get 11 squared is 121 plus 16 is 137. So our equation, guys, is going to be x plus 2 squared plus y minus, y minus 1 squared, not y minus 5, equals 137. Okay. All right. So for example 3 here, we have to determine the intersection points between y equals x minus 5 and this circle here. Okay. Guys, what I'm going to do here, I'm just going to throw this question into decimals first, just so we can see what it looks like over here. There's our line y equals x minus 5, and then we have x plus 3 squared plus sorry guys. All right, sorry guys, I did this question earlier on. There was definitely a typo here. Bear with me for a sec. Sorry guys, we're going to change this example altogether. Give me 1 second here. All right, so guys, we're going to do this example over here. Okay, it's just going to give us, we could have done the other one. It would have just given us non-integer solutions, guys, which is a bit of a pain. But if you see over here, guys, we're getting these 2 intersection points here and here. Okay, so we just need to figure out how do we do this algebraically. Okay, bear with me for a sec here again, guys. Let's change this to y equals x plus 3. Let's change this 16 to a 25. All right. Please make that change over here, guys. This question will work out much better for us this way. So this unit, guys, is about solving systems by substitution, by elimination. And hopefully you can see, guys, that this is set up very nicely to solve by substitution. If I have y equals x plus 3 here, I can take x plus 3 and I can replace the y in my circle equation. So when we do this, we're left with x plus 3 squared plus x plus 3 plus 1 squared equals 25. And now this is just a quadratic. Okay, so I'm going to go and expand this out like this. And at the same time, guys, I'm just going to subtract 25 from both sides, set one side equal to 0. And now I'm going to expand these binomials. Okay, got a whole bunch of like terms I need to collect here. So I have 2x squared, 3x plus 3x is 6x, plus 4x plus 4x is 14x. 9 plus 16 is 25, minus 25 is 0. So we get this. And then if I factor out a 2x out of this guy here, and we get x equals negative 7. Okay. Lastly, guys, we just need to figure out what our y values are. So we get xy equals 0, 3. And when x equals negative 7, we get y equals negative 7 plus 3 equals negative 4. And that's going to be negative 7 comma negative 4. And those are solutions for this system. Okay, so this kind of matches up with what the graph that we saw earlier on. Okay, guys, we're doing the exact same thing for example 4 over here. We have a line y equals x plus 2. Guys, I'm just going to go ahead and solve this one graphically too. I hope that this one works better than our last one did for us here. Solving this guy graphically, we're going to get x plus 2, and we get x plus 1 squared plus y minus 2 squared equals 13. And doing this, we're going to get these two intersection points here and here. Okay, so we're good idea, guys. Do it graphically first to figure out what your answers are going to be, and then we'll just go ahead and solve it algebraically next. So solving this guy algebraically, we're going to go and solve this by substitution. And I'm going to take this x plus 2, which you can get substituted into the equation here. So what we get is x plus 1 squared plus x plus 2 minus 2 squared equals 13. Those 2's cancel out, so this is just going to be x squared. Just going to bring this negative 13 over here as well. So what we're left with is 2x squared plus 2x minus 12 equals 0. And if I just factor 2 out of this, like this, all right, so we have x equals negative 3 and x equals 2. Now, we're not finished yet, guys, because we still need to figure out the y values. So we have y equals x plus 2. When x equals negative 3, we get y equals negative 3 plus 2, which is negative 1. And when x equals 2, y equals 2 plus 2 equals 4, and we get the point 2 comma 4, which is the 2 points that we saw on our graph earlier on. All right. Okay, so guys, if you're watching this video at this point, I'm going to say that this topic here is definitely going to be an AP topic over here. So if you're in my regular class, guys, feel free to keep watching this question. We're going to show you how this one works. But otherwise, just stop in here, guys. But this is going to be more of an AP type topic over here. What we're going to do here, guys, is we're going to solve. So in this case, we have 2 circles. Okay, and give me a second, guys. Let's go and solve this one graphically first. So we're going to go and all right, so we have 1 squared plus y minus 2 squared equals 25. And we have a much bigger circle here. All right, so guys, we kind of zoom out over here. We can see that we're going to get an intersection point here at -1,7 and another one here at -4,6. So these are the two intersection points that we're having here, okay? Now, algebraically, how this is going to work is we need to solve this one by elimination. Now, elimination is going to work, but first what we need to do is we're going to have to expand out both these equations. So for circle number 1, we get x squared plus 2x plus 1 plus y squared minus 4y plus 4. And I'm just going to do this, bring the 25 over here as well. So we're going to get x squared plus y squared plus 2x minus 4y. 1 plus 4 is 5, minus 25 is -20 equals 0. Okay, so this is going to be the first equation over here. Let's do the same thing for the second equation. All right, guys, that was pretty quick over there, but I just expanded out those binomials over here. And I'm just going to regroup this guy as x squared plus y squared minus 8x plus 26y. 16 plus 169 is 185, minus 425 is minus 240 equals 0. Okay, so now we have these two equations over here. What I'm going to do next is I'm going to stack these two equations on top of each other like this. And hopefully what you see is that we're set up for elimination next. Okay, so if I subtract these, hopefully you see the x squareds and the y squareds are going to disappear. So those cancel out, those cancel out. 2x minus 8x is 10x. -4 minus 26y is -30y. -20 minus -240 is 220 equals 0. Okay, so the idea we have here, guys, is now what I'm here, I'm just going to divide this whole thing by 10, and I get x minus 3y plus 22 equals 0, or I get we get this equation over here. Okay, so over here, guys, this elimination, definitely why this is an AP topic over here. When we subtract these two circles, we're not left with one equation with one variable. We're left with one equation with two variables, and so this is still going to be a linear function. I guess what I'm just going to do here, guys, is I'm going to go back to our graph, and I'm going to graph this y equals 1/3 x plus 22 over 3. So if we look at this one over here, what we have here is we have this black line. Now, guys, it's going to be tough to see when you zoom in over here, but if you zoom in, and I look at the black graph and the green graph, the place that they two intersect is the same spot that the two circles intersect. If I do this one with the purple graph instead, same thing. My black graph is intersecting with the purple graph at the same two spots over there. So what we're going to do next is we're going to solve, I'm going to solve a system with the line and one of these circles now. Now, it doesn't matter which circle I use over here, guys. And other thing I'm going to do is I'm going to use this equation over here, and I'm going to use this equation over here. So I'm going to want to solve these. So this line in this circle now, I want to determine the intersection point here. So this is going to be, we have x minus 3y equals negative, sorry, plus 22 equals 0. Okay, and we have the circle is x plus 1 squared plus y minus 2 squared equals 25. I'm just going to solve this guy for x, 3y minus 22. And I'm going to make this substitution here. Twenty-one times 21 is 441. Okay, and I'm going to clean this expression up a bit. So we get 9y squared plus y squared is 10y squared. Negative 63 minus 63 minus 2 is negative 130y. And I have 441 plus 4 minus 25 is 420 equals 0. And I'm just going to factor 10 out of this guy here. Which factors to y minus 7 times y minus 6. So we know that y equals 7, and we know that y equals 6. So I'm just going to finish this work over here, guys. When y equals 7, we have x equals 3y minus 22, x equals 3 times 7 minus 22. 21 minus 22 is negative 1. And when y equals 6, x equals 3 times 6 minus 22 is 18 minus 22, and that gives x equals negative 4. All right, so this is going to be our two intersection points of this circle over here. Okay, example 6, guys, very similar type of question over here, just the numbers are getting bigger, okay, but it just, we're going to try to go ahead and finish this guy. So for the first one, I'm going to simplify this circle. So I'm going to expand this circle, not simplify. All right, so there's our equation number one. Do the same thing for the second circle here. Guys, that was quick, but to make sure all I'm doing is kind of expanding these binomials here. And we get x squared plus y squared 400 plus 729 minus 1105 equals 24. And we get this guy over here. So now I'm just going to stack these two equations over top of each other. X squares and the y squares cancel out. 40 minus negative 8 is 48x. 54 plus 6y is 48y. 24 minus negative 264 is 280. No, 288. Okay, and this works out very nicely, guys, because we can factor out, I can just divide this whole equation by 48 and get x plus y plus 6 equals 0. All right, so let's continue this on the next page here, guys. I have the equation x plus y plus 6 equals 0. I'm going to use one of my circles. I'm just going to use the smaller number circle here, guys. I think it's easier. Okay, so in this one over here, I got y equals negative 6 minus x. And this is going to go in to here. All right, so let's expand out this guy. We get okay. Now, guys, this guy factors again really nicely for us to x minus 12 and x plus 11. So we get x equals 12 and we get x equals negative 11. Okay, so I have y equals negative x minus 6. when x equals 12, I get y equals negative 12 minus 6 is negative 18. We get 5. And we get these two intersection points right here. So guys, I know that was definitely a very long lesson over there. I hope that this is making sense for you guys. And just guys, shoot me an email or send me a message if you have any questions about this. And I will hope to see you guys all in class soon. See you later.